well, last time we met, Wednesday? Yeah, Wednesday. We did right triangle trigonometry, solving right triangles, Pythagorean theorem, your usual trigonometry that you have, opposite over the hypotenuse, all that good stuff. That only works with right triangles. Don't have a right triangle, and this stuff that we did works for any other kind of triangle. What we're going to start now is we're going to shift it over to all triangles. Okay, now you want to use, if you have a right triangle, you want to use the right triangle trig, you want to use the Pythagorean theorem. What we're going to shift over to is stuff that will work if you don't have a right triangle. And this is stuff that's a little bit more applicable. The stuff we do in Chapter 8 actually is still used for a lot of professions. A lot of places it is important stuff. It may seem contrived with some of the word problems, but they do. These are things that are used still today and have been used for ages. So today we're dealing with the law of sines. Now the law of sines works if you have these situations. Okay. If you have a triangle that has two angles and a side, if you have two angles on the side of a triangle, and like I said, these are not right triangles, these are any triangles. If you have two angles on the side, the law of sines can be used. And that is the law of sines. The sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of C over side C. Basically, the law of sines is a proportionality. The side of an angle and the side opposite is proportional across the board. So if I have an angle and the side opposite, I can find whatever else I need. That's the key. You have to have an angle and the side opposite. Okay, you have to have an angle and the side opposite. Now, the other thing that's also true about the law of sines is the inverse is true. A over the sine of angle A is equal to side B over the sine of B, which is equal to C over the sine of C, which is true for all proportions. Any proportion you have, you flip it over, it's still equal. Okay, that's a really nice thing about solving proportions. You flip it over, it's still equal. Which one of these versions I use all depends upon what I'm looking for. If I'm looking for side length, I use this bottom one. I put the thing I'm looking for in the numerator. If I'm looking for an angle, I use the top one. I put that in the numerator. I don't put it in the denominator. It's harder to solve when it's in the denominator. If it's in the numerator, it's easier to solve the equation. Does it really matter which one you use? No. I just put whatever I'm looking for on top. It tends to work a little easier that way. Okay. And these are, once again, for standard triangles, standard way of labeling a triangle. Vertices are capital letters. The sides are lowercase letters. Opposite the angles. So the first thing you do when you have a question like this, draw a triangle and label it with the information that is given to you. That's the first thing you need to do anytime you're trying to solve a problem. So I have triangle A, B, C, and it doesn't matter the order of the angles you put them in. You can put them in any one you want. You only got 3, it doesn't matter. And then let's see, I know that this is a 45-degree angle. This one here is a 40-degree angle. And the side between them is a 4 units long. And if I don't give you the specific units, you don't need to give me units in your answer. Okay, so if I said it was 4 centimeters, your answer should include centimeters. But if I don't put units, you don't put units. Okay. Now, so we need to find the missing parts. Okay. I like to start with the easiest missing part that I can. C. Angle C. Angle C. Why not? Why not go the easy route? Do the easiest thing possible first. And you actually need to get it before you can do anything else anyways. Angle C is equal to 180 minus 40 minus 45. Right? 180 degrees in a triangle. Subtract the other 2 angles. Angle C is, what do I have here? 95 degrees. So yeah, you absolutely need to have that anyways. And I always like to start with something easy first, because starting with something easy makes you feel good, right? I know I got this right. And you're feeling good when you're starting out, right? Look on it when you're taking a test. You look for the easy question. Yeah, I got this one done. That's why a lot of tests have the easiest question first. That's why I did all the 3-point questions.
Yeah, I do too.
I get that. I get that. Well, I had a teacher once that wrote a test to put the hard questions first and easy questions last, because he was kind of curious of how it went. I don't remember. It's like my second year teacher, and I don't remember what the results were. And it was an identity test too. Okay, so part of the reason you need to do this one first is in order to solve. One of the things you have to use the law of sines is you have to have a side and an angle that are opposite each other. If you don't have this relationship, you can't solve using the law of sines. You have to have a side and an angle opposite, or it doesn't work. Okay, you have to have that initial proportion. Then any other ones you can find. So let's look for B next. Okay, just to make it alphabetical. Or reverse alphabetical, depending on how you want to look at it. So we're going to solve for B next. It's not a problem. I have the ratio I know here. 4 over the sine of 95 is equal to B over the sine of 40. And remember, you are supposed to be in degrees for this. And this is what I like when it's set up like this. I just multiply both sides by the sine of 40. Gets me B by itself. B equals 4 times the sine of 40 over the sine of 95. And B equals, and here's where you need to be careful when you're doing this on your calculator. If you type it straight in, 4 sine 40 divided by sine of 95, if you don't use parentheses around the sine of 40 or something like that, your calculator may just take 4 times sine of 40, but take 40 and divide it by the sine of 95 before it takes the sine of that number, rather than doing the sine of 40. You just got to be careful how you do stuff. And you do that, and you get B equals 2.58. And you should do these to make sure you're getting the right numbers.
So why did we use like 4 and sine 95 and then sine 40?
Because these are opposite and these are opposite, and that's what you do it. You do it with the opposite ones, right? Because if you look at it, what it is here, it's A over sine of A over sine of A, B over sine of B, C over sine of C. But you have to have an angle in the side opposite, where you can't set up the proportion at all. Okay? So we figured out what B is. Now we got to do the same thing for our last side. So C over, sorry, not C, we have C. Side A is what we're looking for. A over the sine of 45 is equal to 4 over the sine of 95. And this is one of those ones, like I mentioned the other day, use given information as much as possible. Say found information, use it only when you have to. But 95 degrees, come on. It's not like you're going to screw that one up. It's not some big long decimal you're rounding off. It's an exact value, you're fine. Multiply both sides by the sine of 45. A equals 4 sine of 45 over the sine of 95. And you get A equals 2.84. Yeah, I like it. You can now work with solving parts of non-right triangles. And I like a lot of sines. A lot of sines is easy to set up. It's easy to remember. It's easy to use. Okay, there are some issues with a lot of sines. We'll come to that near the end of the notes. Any questions? Okay. Just saying, not to scale. Just saying, not to scale. Two people 400 feet apart measure the angle of elevation of the top of the tree at 51 degrees and 65 degrees. How tall is the tree? Okay, this is the situation we have going on. And what we're being asked to do is find the height of the tree. Now, our final goal, the thing we're looking for, is we're trying to figure out that right there. What's the height of the tree, right? So that's what we're looking for. So what we want to do is say, okay, we want to find that height there. And we know that that's 51 degrees. But we need two things, a side and something else, to find the other parts of a right triangle. I have an angle. I need one of these two sides. This is not necessarily split proportionally. So I can't just take 400 over 61 and I can't take 65 and 51. And it doesn't necessarily split proportionally. So I can't use that. But what I can do is I go, wait a minute, I've got two triangles here. Actually, I technically have three. But I also have this triangle here. And if I figure out what this is, that's what that is. Does that make sense? Right here. If I can figure out that distance there, then I can figure out what's going on. And I can use a lot of signs to find that one out. Thanks. So, once again, in order to do the law of sines, I have to have the angle opposite the side. But if I have these two, not a big deal to get the one on top. You do your subtraction and you get this as being 64 degrees up there. And now I can set up my ratios for that. X over the sine of 65 is equal to 400 over the sine of 64. Multiply both sides, you get x is equal to 400 sine of 65 over the sine of 64, and you get the length of x to be 403.34. And you know, that makes sense. The angle here is just a little bit more than the angle here, so the numerator here should be just a little bit more than the numerator there. That makes sense. So I ended up getting this side here to be 403.34. And now I can move to this right triangle, and I set up my right triangle trig, and I can solve it out. This angle, that height, this side here, opposite over hypotenuse, this would be the sine. The sine of 51 degrees is equal to h over 403.34. So my height is 403.34 times the sine of 51 degrees. So the height of my tree would be 313.5 feet. Once again, this is not proportional drawings. That tree is 313 feet tall. That would make those guys about 200 feet, give or take. We do not have 200 feet people. I mean, you know, maybe if you're in the you know, stuff. You might remember the attack of the 50-foot woman, but it's a bad, cheesy sci-fi movie from the 50s. It's actually, it's a cult classic now. But yeah. In which, by the way, if you know your geometry, it is impossible to have a 50-foot person.
Are you sure?
Yes, I am.
Yeah, we
Yeah, the bone structure would not support the weight. Because, okay, hang on. Okay. Now, I like this problem for several reasons. So, to measure the height of a mountain, the surveyor takes two sightings. The peak at a distance 900 meters apart on a direct line to the mountain. The angles of elevation are shown. If the surveyor's equipment is 2 meters tall, what is the height of the mountain? Well, actually, I think the height of the surveyor's equipment is relatively irrelevant to the real world. However, the Chinese used this method couple thousand years ago. Well, I think around 300-400, maybe actually even before that. Okay, not years ago, 300-400 AD is when they figured out the height of Mount Everest using triangulation, using the law of sines, using stuff like this. They surveyed the entire country, and their height of Mount Everest was only off by a few feet from what it was later measured in satellite. And they use satellites now for the measurements of these things, and the mountains do fluctuate in height a few feet every year. Snowpack, melt, grow. They have a big storm comes through, it's a little taller. They have a storm goes away, they actually do fluctuate a little bit. Okay, but yeah, they did this by walking around with surveyor equipment and doing trig like you're doing today. Now, so this is what we can use. We have this triangle here. We can do the same thing that we just got done doing. Same idea. We have two triangles. We have this triangle. We actually technically have three triangles that we have to deal with. But we have two right triangles. We do the same thing we just did for the tree, but we use this one here to find one of these two sides. Now, which one did I find? Well, I found this is the one that I found in my notes. This is what I'm going to do today.
Which one? That
one. I could find, if I wanted to, I could find that side. That would work too.
Do you know what that side is?
No, I don't know off the top of my head. I did one in my notes. I didn't do it both. And I would not require you to do both. So we have to figure out what we need to do this triangle. Well, okay, we got some stuff going on here. What's this angle measurement down here? 133. And what's this angle measurement up here? 12. Two ways to get that one, by the way. 180 minus these two angles, but there is another one. Do you remember the exterior angle theorem? This angle is equal to these two angles added together. 47 minus 35 also gives us our 12. I don't expect people to remember that. The only reason I really remember this teaching geometry all those years. There are certain things like that I remember. So let's do this one first. 12, 900, x, and 133. Use your law of sines. I'm not including the other angle because frankly I don't need it for what I'm doing here. X over the sine of 133 is equal to 900 over the sine of 12. X equals 900, the sine of 133 over the sine of 12. X equals 3165.9. It's close enough for what we're doing here. So now we know this length here, 3165.9. So now I can go and say, ooh, there we go. That's my triangle I want to set up to find the height of the mountain. And because I got a right triangle, use right triangle trig. Law of sines does work with this stuff, but realistically, I'm going to have this over the sine of 90 degrees. What's the sine of 90 degrees? 1. That's why we kind of ignore the law of sines when we do this stuff. Okay, it does actually work, but we don't. When you have a right triangle, use your right triangle trig. Don't mess with the law of sines. Just use that for non-right triangles. So that means the sine of 35 degrees is h over 3165.9. The height is 3165.9 times the sine of 35, which gives us h as 1815.9. However, if we read the directions carefully, or read the problem carefully, what else do we need to do? Add 2 meters for the height of the equipment. Those surveyors have got to be tall if it's 2 meter equipment. You know, I don't. The actual mountain height is 1817. Or actually, let's call it 1818, rounding off. Yeah, because it says the surveyor's equipment is 2 meters tall. Okay, 2 meters. Okay, I don't know if I could use 2 meter tall survey equipment myself. Okay, I mean, I'd have to be standing on my tippy toes to look through it. That'd be, you know. Yeah, yeah. I mean, I'm just a hair under 2 meters myself, so the equipment's taller than I am. I don't know who's using this freaking surveying equipment if it's 2 meters tall.
They're standing on a rock. They are standing on a rock.
No, he's only got 1 foot on a rock.
You don't know that? The other foot could be dangerous. They had to like.
Yeah, but the bent knee's on the rock.
They have incredible quads.
I know. Okay. So, we good with this? All right, here's where we start running into issues, though. The law of sines does have a problem. Now, if you go back to the beginning problems that we did at the very beginning of the notes, we talked about if you had 2 angles on the side, angle, side, angle, or angle, angle, side, doesn't matter where the 2 angles. If you have 2 angles on the side, you're good, no problems. You're never going to have an issue with the with the law of sines. However, if what you have spells a bad word, you're going to have problems with your law of sines. Okay? So, if you have an angle and 2 sides, and the angle is not between the 2 sides, the angle is between the 2 sides, we'll deal with that when we come back on Monday. But if you have an angle not between the 2 sides, you have problems with the law of sines. Okay? There may be more than one possibilities. It may never work, and there may be no triangles that exist with that angle and side-side combination. There may be one triangle that works, or there might be 2 triangles that work with that situation. So the one with the angle side-side, you can have this angle and this side X, and this one is so short, it never comes down and touches. So it can't actually exist. That is the one that doesn't exist. You have a problem like that. Your one triangle is your standard one triangle. It works. Your possibility of two triangles takes place when you have a setup like that. It is entirely possible to have two triangles that have the same angle and two sides, and have it not work, and have two possible triangles. How do you figure out what to do? Well, first thing you do is you get an angle. You use the law of sines to find an angle. Okay. And then you test 180 degrees minus that angle found to see if you have another possibility or not. Okay? First thing you do is find an angle. After that, you try to see if you can find another angle or not. Okay? And it's going to be the first angle you find is the one that you're going to have to go off to test the other possibilities. Now, the reason why you might have these issues, think about your sign, and we kind of got to go back to the unit circle at this point. So if I think about the unit circle, the sign gives me my y value, right? So if I have an angle going off here, an angle theta, its y value is here. Well, if I have another angle over here that measures over to that, they can both have the same sign. This angle here and this angle here both have the same sine measurements. And so when I do the inverse sine, your calculator will always give you the smaller of the two. It does not give you the larger possibility. That's why you take the one that your calculator gives you and subtract it from 180 to give you the other angle. So your calculator gives you this small acute angle every time. When you do the inverse sine, it will not give you a number over 90 degrees. But there might be one that's more than 90 degrees that also works as well. And that's why we have to test, because it is possible there are two angles that have the same sign. And if you're using the law of sines to find an angle, that's where you run into problems. If you're using the law of sines to find a side, you don't have any issues. If you're using the law of sines to find an angle, that's where you have problems, and that's what we're dealing with here. First thing you do, draw a triangle and label it. Okay. If we get to a test and I say, give you a problem like this, and you don't have the diagram to go with it, I'm going to be very unhappy with you. So I have this side's 9, and this side's 14, and this side's 95. Okay. So now I have to solve for the missing parts. Angle A is the only thing I have enough information to solve for, because what do you have to have? You have to have the opposites. Right? So law of sines works with opposites. I have angle B in the side opposite. I have the short side A, so I can look for the angle opposite that. So I set it up. The sine of angle A over 9 is equal to the sine of 95 over 14. Okay. Multiply both sides by 9. I get the sine of A is equal to 9 times the sine of 95 over 14. A is equal to the inverse sine of 95, or sorry, 9 times the sine of 95. Over 14. Then I get angle A to be 39.8 degrees. Easy enough, right? Okay. finish the triangle out, see if the stuff works. We'll go from there. So angle C is easy enough. Right, angle C is 180 minus 39.8 minus 95. So angle C is 45.2. And now I can find side C using that and the law of sines. So B over the sine of 45.2 is equal to 14 over the sine of 95 degrees. I'm looking for side C. You're right, C. My bad. I always make at least one mistake. Thank you for pointing it out to me while I'm recording. Now people at home will know that I am flawed and not perfect. Well, not like anybody really watches these that much.
Yeah.
No, I have students that do, and some classes more than others. You know, some are better about it than others. I did actually have one video one time I was check the information, and it said that I had 3% was a Russian viewer. Like, okay, whatever. Only had 9 views, and one of them was a Russian. Okay. So C equals 14 times the sine of 45.2 over the sine of 95. The third side is 9.97. Okay. So we found a triangle that works. Obviously, we don't have one that doesn't work, which can happen. We have one that does work. Now we need to check to see, is there another possible triangle? So to do that, we take the first angle that we found, and that's the one we use. So we take 39.8, subtract it from 180. 180 minus 39.8 gives us 140.2 degrees. This will not work. This will not work. A couple of reasons why I can eliminate it without doing much of anything else. If I take this angle here at 95 and add it to 140, 95 plus 140.2 is greater than 180. It is not possible to have 2 out of 3 angles add up to more than 180 degrees in planar geometry. It is in 3-dimensional spherical geometry, but not in flat plane geometry. Can't be more than 180. So it won't work. The one given to me and the other one, just they add up to too much. But here's the other thing. And this will be extremely helpful to kind of keep in your mind when you're doing some of the stuff with the triangles. One of the rules of triangles is the largest angle is opposite the largest side. The smallest angle is opposite the smallest side. So I have a 95-degree angle opposite of 14. I am not going to have a 140-degree angle opposite a side smaller than 14. This has to be the largest number. If this angle up here is bigger than this angle here, this side needs to be bigger than that side or it won't work. So there's a couple of ways to tell. Obviously, the 2 angles adding up to more than 180 is going to eliminate right off the bat. So what I found here is my only possible triangle. The triangle exists. This is what it looks like. Okay? Question. Okay. Draw the diagram, get that set up and ready to go. Okay, once again, first thing you do, draw a triangle, label it appropriately. Okay, label the information you know. If you want to put down there the information you're looking for, you can do that, but right now just label it with the information you know. So what we have, there's only one thing that we can find, angle B. Because remember, you have to have angles and sides opposite each other to use the law of sines. Because I have these two, angle and side, and I have that side, the only other thing I can do is look for angle B. So I set up the sine of B is sine of B over 7 is equal to the sine of 65 over 6. Okay. Figure out what B is. What are you getting? Error. Your calculator's saying, stupid, you can't do that. That's what error means. Just so you know, I'm translating calculator speak for you, but they stupid, you can't do that. Do me a favor. Do me a favor. Calculate the sine, 7 times the sine of 65 divided by 6. Do not do the inverse. Just calculate that number. What do you get? 1 point something. What is the largest possible value of sine?
0.9.
What's the maximum value of sine? Oh, come on, you should know this. 1. The sine fluctuates between two numbers, 1 and -1. You cannot take the inverse sine of something that does not exist. The sine of any angle will never be larger than 1. So you cannot take the inverse of a number larger than 1. That's what's happening here. So what's my conclusion? There is no triangle that exists with those 3 dimensions given. This triangle cannot exist. So there's no solution on this one. Yeah, there's no solution on that one. Okay? Yeah, if it spins it back and the sign says, hey, no, can't do that, that's what happens. It is entirely possible there is no triangle given those 3 parts actually exist. None of the rest of the parts are there. Okay, it doesn't work. Okay. Now, start 7. Set up the triangle, start looking for parts. Practice.
Yes, yes.
Practice.
This is good, yeah.
And sometimes I can even do math upside down. Not always. I can't always do that. Depends on how complicated it is. Sometimes I can do simple math by writing the numbers upside down. Not very often. I can read upside down, writing upside down. Heck, I can barely write normal side up anyway. So. So you solve for the first angle. You get B is 66.6. Okay. Angle C is easy to find. 180 minus 35 minus 66. So angle C is 78.4 degrees. And then if you continue on with the law of sines, side C is 12.81. So we have a triangle that works. We might have two triangles that work. So what we need to do is we need to take the first angle we found and subtract that from 180, see if that gives us a viable number. So 180 minus 66.6 gives us 113.4 degrees. That's entirely possible given the information we have to have it work. So I found side B. So if I do a second triangle, sorry, my angle B, 113.4 degrees, angle C. So 113 plus 65, subtract that from 180, and you end up getting 31.6. 180 minus 113 minus 35 gives 31.6. We have three angles that work. We're okay. And then set up this law of sines. C over the sine of 31.6 degrees is equal to 7.5 over the sine of 35 degrees. And you end up solving it and you get C equals 6.85. A doable triangle. A doable triangle. So once again, if you're given two angles on the side, you have no issues. There's one triangle that's going to work for that. You can do everything. If you're given two sides and an angle, that's where you might have problems. That's what you need to watch out for. Okay? Questions? Okay, your assignment's on the board and on the paper I gave you the other day. Oh, crap.